Okay, in this section we're going to talk about some special factoring techniques. Remember when we did our multiplying polynomials and we said we had those two special products? Okay, and one looked like this. And one looked like this. And we said we had shortcuts for multiplying those out. Okay, this one multiplied out to be the difference of squares, and this was a perfect square trinomial. And the way we recognize them is, look, everything is exactly the same except for the sign in the middle. Okay, that's going to be something called the difference of squares. When we multiplied it out, remember, you squared the first one, you squared the last one, and it was always a minus. So that means, hey, if I haven't multiplied out and I want to go backwards to write it as its factors, here's my formula. And I just got to memorize this. It'll be way easier to memorize if we memorized how to multiply this out. So I should be able to go back and forth between these. Okay, this one, we said the shortcut is you square the first one. You multiply the two terms together and double it. And then you square the last one. So if I start out with a trinomial that looks like this, right, with those two conditions, which we'll talk about this one later, we're going to do the difference of squares first, then I should be able to go to its factored form. Okay, so let's focus on this one first. Okay, in order for two terms to factor, now remember when we started factoring, we started out with 4 terms and said, okay, use factoring by grouping. Then we went to 3 terms, those trinomials, and we were finding our 2 special numbers. Now, if I have 2 terms, in order for 2 terms to factor, the first term has to be something squared, the last term has to be something squared, and there must be a minus in the middle. If those conditions hold, then I know how it factors. I just write the square root of each one in each binomial and then put a plus and a minus sign between them. So if I've got a plus sign in here, it will not factor. The sum of squares does not factor. The sum of squares does not factor. It's got to be a difference, and they both have to be squares. Okay, so let's look at what that means. Okay, so factor each binomial. Hey, if I'm trying to factor a binomial, then I need this to be something squared and this to be something squared. And notice I can write 64 as 8 squared. And this has to be a minus. If those conditions hold, then I know how it factors. I just put these square roots in each term. One gets a plus, one gets a minus. Okay, let's look at this one. This has to be something squared, and this has to be something squared, which it is, that's 6 squared, but there's a plus. The sum of squares does not factor. The sum of squares does not factor. There's a 95 to 99% chance there's going to be a sum of squares on your final exam. Do not factor the sum of squares. Right? It's got to be a minus sign. Okay. So everything in the first term has to be a square. Everything in the last term. That's a minus, so I'm good. So I can rewrite this as 3 squared and y squared, right? And this is 11 squared. As long as that's a minus, and I can figure out these values, this is what goes in my 2 factors then. The 3y and the 11 goes in each one. And one gets a plus and one gets a minus. It doesn't matter which one gets the plus and minus, right? We're multiplying. And it doesn't matter the order. Multiplication is commutative. Okay, so it's two terms. Everything's got to be squares. That's 5 squared, that's z squared. Wait a minute, that's not something squared. Right? Those conditions have to hold or it will not factor. Okay, think about this. I got two terms and I see that that's 9 squared. So I'm good with that. But y to the 4th, is that something squared? It certainly is. It's y squared squared. Remember our exponent rules? Right? So it turns out any even exponent is a square. Because look at this. What if I had y cubed squared? That's y to the 6th. Right? Y to the 8th is the same thing as y to the 4th squared, and on and on and on. So an even exponent means it's something squared. So okay, so I've got y squared, and we've got the minus. Okay, that means once I can figure out what my square roots are, here and here, that's what goes in my factors. One gets a plus, one gets a minus. Now, think about this. We mentioned this before. Anytime I wind up with one of my factors that has an exponent bigger than 1, I got to keep trying to factor it. So I got it, this has an exponent bigger than 1, an exponent bigger than 1. I got to keep trying to factor that. This is the sum of squares. It will not factor. But look, I wound up with another difference of squares. This doesn't factor any farther, so it stays y squared plus 9. But this one, my square roots are a 3. Y and then 3. Okay, now they have an exponent of 1. I don't have to keep trying to factor it. But notice we got to completely factor, right? Completely factor. Okay. Even exponents mean, yeah, I can write that as a square. This number is not something squared, and this is not, but don't forget, first step goes without saying, look for a common factor. So this one's not even. 4 and 8 is 12, so this thing's divisible by 3. 6, 7, 8, 9. Oh, they're both divisible by 3. Let's see what we get if we factor out a 3. 48 divided by 3 is 16. You can go over to the side and figure that out if we need to. 243 divided by 3 is 81. And now I see that's something squared, something squared, something squared, something squared, and it's a minus. It's going to factor. I need the square root of 16, the square root of m to the 4th, the square root of 81, the square root of n to the 4th. One gets a plus, one gets a minus. Hey, I still got exponents bigger than 1. I got to keep trying to factor this thing. This won't factor anymore. So the 3 stays and this stays. But all of these are squares. 4, m squared, 9, n squared, and it has a minus. So that factors again. Square root of each one. So a 2m and a 3n. 2m, 3n. One gets a plus, one gets a minus. And now I don't have any exponents bigger than 1. The difference of squares. Okay. Now, the other special product we talked about was a perfect square trinomial. right? It's a trinomial, but we can write it as something squared. Remember when we had these products and we said our shortcut to multiplying it out was square the first one, multiply the two terms together and double it, so times 2 and square the last one. So if I want to use a shortcut for factoring these, now on the difference of squares, I got to memorize that. I got to memorize the difference of squares. That's how my two terms are going to factor. Technically, this is a trinomial. It's got those 3 terms. I could still find my 2 special numbers. It would work. But when those numbers are big, this is really helpful for us. So we are going to talk about it. All right. To know if a trinomial is a perfect square trinomial, the first term and last term have to be something squared. And then the middle term has to be 2 times their square roots. You have to have a plus sign in the back, but you can have a plus or minus in the front. So let's look at some. Okay, so here's my question. Yes, that's something squared. That's x squared. This is 10 squared. So is the middle, here's my, and that's a plus, so I'm good with that. Here's my question. Is the middle 2 times x times 10? 2 times 10 times x. Oh, yep. If that's the case, I know immediately how it factors, right? I use this first sign, all squared. Okay, let's look at it again. Don't forget to look for a common factor, but there's not one. Is this something squared? Yes, it is 3z squared, 3 squared z squared. This is 8 squared. Is the middle term 2 times 8 times 3z? That's the question. So let's see what this is. 2 times 8 is 16 times 3 is 48. It is not a perfect square trinomial. So don't forget, you got to check, right? You got to check and make sure both of those conditions hold. Okay, so if it's not a perfect square trinomial, we just go over here and continue to factor it like before. Okay, so I need 2 numbers that multiply to give 64 times 9. $576 and add to give 16. Okay, so let's see. The numbers are going to have the same sign, so they're going to be fairly close together, right? Right off the bat, think this is going to be prime, but let's look. Let's change this to 64 times 9 and look at some of our factors. So this is 8 times 8 and 3 times 3. So one thing, we have 24 and 24, but that's not 16. Okay, and of course 64 and 9 is not 16, so let's try this. Let's try to go a little farther. Okay, my 3's are done. Okay, so we have 9 times 4, we have 36 and 16. That's not 16. All right. So in the end we have 1, 2, 3, 4, 5, 6 2's and 2 3's Okay, so let's see if we can rearrange this a little bit. Let me get rid of this and get us some room. Okay, so 2 times a huge number. This is actually 9 times 64. We've got it up here already, and that doesn't add to give 16. Let's try 8 times 72. That's not 16. I don't see, let's put our numbers up over here. 48, 52, 73, 80. I don't see how we're going to get any factors of this that add together to get numbers as small as 16, right? That's just not going to be happening for us. Look how big they are. Okay, and if we try to 2, they're really far apart, and a 3 and a 4, right? We would need some numbers up in this size. It's just not going to happen. Okay, so it doesn't matter if just these numbers are squared. This middle condition has to also be met. All right, let's try that one more time. Okay, what do you think the first thing we need to do here is? You bet, factor out that y. Don't forget that's always your first step, greatest common factor. Okay, 16 and 49 don't have anything in common, so the y is the only thing coming out. But hey, 16 and 49, it's real easy to tell if these are squares right off the bat. 16 is 4 squared, and of course y. 49 is 7 squared. So my question is that middle term 2 times 7 times 4y? Okay, 2 times 28, 56. Oh, if that holds, I'm done with my factoring. Make sure it holds though. Don't forget we've got the y out here. And then I use the square of the first one, the square of the second one, the square roots. Use this sign because that one has to always be plus, and it's all squared. Okay, so some special factoring techniques. The difference of squares and a perfect square trinomial.